Unit 3. Let's begin with Unit 3. So this first lesson in Unit 3, as we move into what's called trigonometric functions and polar functions, that's what Unit 3 is going to be all about. We're going to start with this idea of something being periodic. Now, periodic is going to be repeating, as we'll see this in a second. So today we're going to be looking at constructing graphs of periodic functions or relationships, and we're also going to learn some key characteristics that describe periodic functions. So what does this word periodic mean? On your second slide, you have this. And what I've done is I've actually given you two different definitions. Up here, it's just basic English, and down here is the mathematical. The mathematical is confusing. That's why I'm actually giving you two definitions. So here's the one that makes more sense. A periodic function is any function that repeats its y values on regular x intervals. So what do I mean? If you have a graph, just draw a graph up here. I'm going to do what's called the sine curve. What happens is you have a graph that repeats its y values over the same distance as you go right to left. Or I mean left to right, excuse me, I said that backwards. So as you go left to right, the y values repeat. So most graphs are going to look like waves. Like that. Okay, they don't have to be waves, but most of them will be. Notice the y values are repeating. This gets as high as this point, it gets as low as this point, and they repeat. It goes up, it goes down, it goes up, it goes down, it goes up, it goes down. Does that make sense? That's periodic. When you hear me say periodic, that's what we're talking about. It's repeating. Mathematically, anything that can be written in this form is periodic. I need to make one change here. I caught this yesterday. I said natural number. If there is a natural number n, change this to an integer. So technically, I would need to say an integer. There is an integer. Do you remember what integer means?
A number that's positive.
It can be positive or negative, but it cannot be.
Irrational.
It can be zero.
It can't be like.
It can't be a
Can't be a fraction. Can't be a decimal. It's got to be a whole number, but it can be a negative whole number as well. So whole numbers are 0, 1, 2, 3, 4, 5. Integers are -5, -4, 0, 1, 2, 3, so on. So there's an integer. I guess I don't have to say an integer number. I can just say an integer n and a real number k, for which this is true. We're going to see this come up. I think it's on example 3, as we're going to walk through that definition. And like I said a second ago, I just drew sine. Sine was what I drew. If you want to underline this up here, that was the little drawing that we did at the top of the page. We're also going to see sine, cosine, tangent. There are 3 others, but for the most part, we're going to deal with sine, cosine, tangent, and we will see those as quickly as next class. So lesson 3.2 is going to be about sine, cosine, tangent. All right, with that, there's your definition. Where do we see these in the real world? Oh, all the time. Think about your breathing. When you breathe, you're repeating over and over the same concept. So what we don't do, or what's not normal, is to breathe erratically. Meaning, you don't breathe like. We don't do that. We breathe very consistently. Okay, it's irregular when you're not breathing like that. Heartbeat's the same way. There is this phrase, irregular heartbeat, and that's pointing to someone being unhealthy if their heart is not in a repeating periodic method. So the waves in the ocean, the waves are very repetitive unless you get into a storm. Again, unless something's wrong, it's usually really repetitive, the waves in the ocean. All of a sudden you get in a storm and things start getting crazy. They're not repeating consistently. They're not repeating by the same amount. So all that to say, we're talking about repeating functions. Usually things repeat in the same manner unless something's wrong. If it's not repeating correctly, it's an indication something's up that's not good. All right, with that, let's get some vocabulary out of the way. On the left, I've given you the definitions. On the right, I've given you a picture. I'm going to walk through this over here on this picture. So what does periodic mean? Periodic means it repeats its y values. Does this graph here repeat? It's periodic. This is a periodic. This is periodic because the y values are repeating. Because of, I'm just going to say repeating nature. This is periodic because of its repeating nature. Let's do that. Now, a cycle is one whole wave. In my opinion, you can find a one whole wave anywhere along this path. I think the easiest way to find one full cycle is maximum to maximum. That's what you hear me say frequently because most students don't mess that up. From maximum to maximum, that would be one cycle. One cycle would be from there to there. Now, do I have to use maximum to maximum? No, very good. Way to answer for me. You can use any point along the way. Would still be one cycle. So I'll just change it to here. That's one cycle. Notice I'm just moving mine around using my smartboard. Could I go minimum to minimum?
Yeah.
Yes. You know what you can't do though? Is to go minimum to maximum. Good. That would not be a cycle. Or to go from 0 to this 0 right there, because that would only include the minimum and it would skip the maximum. The easiest way to make sure you don't screw up is always just to go maximum to maximum. Make sense? This distance here, the distance of one cycle is called a period. The distance of one cycle, the distance of one cycle is called a period. So that's the next line. In this case, if you put in the numbers, I can tell you right now, the period. Actually, let's do a little exploratory. I'll tell you exactly what it is in a moment. If you were gonna guess where this point is right here, what would you guess that point's located at? Negative what? We're doing X value here. The period's always X values. What would you say that X value is about right here?
Negative 4.8.
What I heard negative 4.8. What else?
Yeah, kind of.
Okay, what about this one?
I'd say like 1.8.
1.6. 1.65.
Okay, so we're gonna say 1.6. I think 1.8 might be a little bit too much over here. Let's say negative 4.7. So here's how you find distance. You're gonna take the maximum, and it's the maximum X value, and you subtract the minimum Y value. So the maximum X minus the minimum X. So I'm gonna pull up my calculator just so I don't make a stupid mistake here. And so we said the maximum X was approximately 1.6. Was that right? So 1.6, and what we're gonna do now is subtract the minimum X value. Well, the minimum X value was a negative number. It was negative 4. What'd y'all say, 7? Is that what we said?
Yeah.
Okay, now I'm gonna press enter. So roughly this says it is. Now I know what the true answer is because I know what the graph is. The true answer is 2 times pi. Now that's the true answer, 2 pi. Now I want to press enter and look what you get. Yeah, wait, that was a pretty good estimate y'all came up with. Y'all did better than my class yesterday. That was a really good estimate y'all have there. So 6.28, is that approximately 6.3? You bet. Y'all did a great job. So come back over here.
Professional guess.
Yeah, y'all's estimate was pretty good. We can go ahead and put the answer here though. It's going to be 2 pi on this one. And then what I'm going to do is a squiggly equal sign. That means approximately 6.3. And that is because we guessed approximately 1.6. Is that what we said? And then negative 4.7. Yeah, there we go. Okay, that's one period. All right, let's go to the next one. Amplitude. What's amplitude? Amplitude is very similar to period. It's maximum minus minimum, except we're talking about the Y values. So a amplitude, and there's going to be divided by 2. I didn't say that. Let me write that in. How it's going to be, it's now we're dealing with Y values. It's the max minus the min divided by 2. But we're talking about Y values. So with period, I'm going to put X over here. And amplitude's dealing with the Y's. So on this problem, what's the maximum Y value? 1. So it'll be equal to 1 minus, what's the minimum Y value? Minus negative 1, and all of this will be divided by 2. So what happens when you have a negative minus a negative? Excuse me, I said that backwards. A minus a negative. You add them. What's 1 plus 1?
2.
So that becomes 2 divided by 2, which is equal to 1. The amplitude is 1. Now, what is visually the amplitude? The amplitude visually is easiest to see as the maximum to what's called the midline. That right there is the amplitude. Because you think about what we just did, How we started is we found all the way down from top to bottom, and then we cut this in half. And so that became the amplitude there. Does that make sense? So that's the amplitude. It's the top of the wave to what's called the midline. And so that's our last word. What is the midline? The midline would be the line that I like to say axis of symmetry, but it's not true to call it the axis of symmetry, because axis of symmetry would mean this would reflect straight down on itself, but there's nothing down there. But it's the line that cuts the wave in half. That right there is called the midline. Okay, does everybody have time to write all that down? What are the only two values we actually had to solve for? Period and the amplitude. Period and the amplitude. Period deals with x's. Amplitude deals with y's. All right. Let's go on to some examples here. The first thing we're going to do here on example 1 is just look at these graphs and determine, are they periodic? And if they are, we'll find the period and amplitude. If they're not, we're just going to say it's not periodic. Let's look at this first graph. These arrows did not come through well, so I'm going to add this as an arrow here and as an arrow here. What do you think? Does this look periodic to you? Does it look like we're repeating the same values over and over?
Yes.
Okay, this is a periodic function. And I'm using the word function. Remember, a function means it passes the vertical line test. Does this pass the vertical line test? So it is a periodic function. Since it's a periodic function, we're going to find two values. We're going to find the period, and we're also going to find the amplitude. And it says on the instructions to label one cycle. It says label a cycle. Okay, so let's do that. What did I tell you is the easiest way to label a cycle and to label it properly? Now, do you have to do maximum to maximum?
No.
No, you do not have to do maximum to maximum, but I think it's the easiest way to not screw up. It's at the top of the graph, it's clear. You don't have to write over the graph to do it. That's right there, one cycle. Now, how do we find the period? Maximum minus minimum, looking at x's or y's? X's. Okay, so using this cycle right here, what's the maximum in this one cycle? 1. So it'll be 1 minus, what's the minimum on this cycle? Approximately -3. So what happens when you take 1 and you subtract a -3? You add there. And so what do we get? 4. And I'm just going to write the word units. So 4 units. Whatever units this refers to, sometime it's going to be time. Frequently it'll be in this unit time. But here it doesn't say, so I'm just going to say 4 units. The amplitude. How do we find the amplitude?
Minus min, but for the y's.
Yeah, and we need to divide it by 2. Okay, what's the maximum y value you see? 2, and we subtract it by the minimum y value you see? -2. You're going to have a lot of these double negatives. Or what's a minus a negative this unit? It'll become positive, and so you need to get used to that. You'll see a lot of that. 2 plus 2 is 4, and we divide that by 2, and now you can say it. That's 2. And since it doesn't say anything, I'm just going to say units. By the way, period and amplitude. These are talking about distances. It's distances. Now, distance is always positive. So never label a period or an amplitude as being negative because they measure distance. Okay, so visually, if you want to add, you could say 1 cycle, which is equal to 1 period of distance. If you want to add that to your notes. And then amplitude, it's the distance from the maximum to the midline or the minimum to the midline. That's the amplitude. Again, do you actually have to measure from the middle to the top for amplitude? No, you could do it down here as well and see how it's exactly the same. But I'm going to leave it. I just measure to the maximum like that. I'm going to leave it there. Questions so far? Okay, next one. What do you think? Periodic, not periodic? Looks periodic, but there should be something you're going, wait a minute. This arrow right here throws it off. Why does it throw it off? Let me extend it a little bit. I have a smart board so I can help you out. What if I extended it up following the same path to there. Does this line match any of these? The slope? No, you see how that one does not repeat perfectly? So this one would be not periodic. Not periodic. And if you want to put the interval for your notes, since that would be -5 is less than x less than -4, does not follow pattern of -4 less than x less than infinity. You don't have to actually put an infinity there, so I'll just leave it like that. This part right here doesn't follow the pattern of everything to the right of it. Okay, what about, I got 2 more of these, same instructions. What do you think about on C? Not periodic. Why not?
Why not?
It's increasing. The Y's are not repeating. Very good. This is not periodic. Since it's not accurate to say it's strictly increasing, but the function, since the function is generally increasing. If you remember from literally the first day of school, they said strictly increasing means it's always increasing. Every new point in the domain, every point to the right would generate a higher value in the y. And then they said you can say a function is generally increasing. It doesn't mean it's every point is always higher, but for the most part, the function is going up as it continues on its domain. So this would be generally increasing, but it's not periodic because they're not repeating the y values. Okay, what about this last one here? Periodic, very good. Why is it periodic? It's a periodic function. Okay, since it's a periodic function, I know it's been a little bit since we did example A. What were the things we labeled on the graph? Do you remember? The cycle. What's the easiest way to label a cycle? Max to max. Do you have to do it that way? No. So if you get to the AP exam and they have something labeled and it's not max to max, that's okay. But just know that's the easiest way to do it is maximum to maximum. That's one cycle. Okay, in it, we found 2 things mathematically. We found the period. And what is the period again? Of x's or y's?
Oh, X.
X's, very good. It's the distance of one cycle. So mathematically, this would look like, what's the maximum x on this cycle? 2. And we subtract, what's the minimum x on this cycle? I feel like we've had those numbers a few times now. What is 2 minus a -2?
4.
And I'm going to put the word units here because it doesn't tell us. I'm just going to say it's 4 units. Since we're talking about distance, we usually label it units. And we need to find one more thing. We need to also find the amplitude. Now, this is similar mathematically, but slightly different yet. What's the difference mathematically than just max minus min when it comes to amplitude? Over 2. So what's the maximum y value? 2 minus what's the minimum? -1. Good. So I do our math here. We have minus a negative, which turns positive. Again, get used to that math. You're going to see it a lot this semester. 2 plus 1 is 3. And we divide that by 2. Does not simplify, does it? You could do 1.5. Very good. I'll just leave it as 3 over 2 units. Questions over that? All right, you have your first DOL. I'll give you just a few seconds. I want you to repeat exactly what I've done. Determine if these are periodic functions. If they are, label a cycle and find the period and amplitude. If it's not, just state what you think is wrong with it. All right, I'll give you a few moments. Okay, now as we continue on, what we're going to start looking at is some verbal representations, meaning I've shown you a lot of pictures. So now we're gonna do, given the words, let's create the picture ourselves. So example 2 says, sound waves are produced by periodic changes in air pressure. So you're talking, what is it that makes us hear the sound? As the sound waves hit, it changes the air pressure. That's how it works in our ear. At least that's what I'm told. I have no way of confirming whether that's true or not, but I'm just gonna believe it's true, which is risky. But that's what they say it is. So it says sketch a sound wave with a period of 3 units and an amplitude of 2. Now it doesn't give us any other information than that. So we're gonna kind of pick our wave here. I'm gonna start with what's gonna be a cosine wave. Y'all don't know why it's cosine. I'm gonna get to that next class, but it says sketch a graph of a sound wave with a period of 3 units. What does that mean? Period of 3 units.
So the max and min is equal to 3. I'm tracking the max is 3.
Okay, let me say it this way. The length of the x's or the length of the y's will be 3. The length of the x's, to repeat, one cycle is 3, and the amplitude is 2. What does that mean? So is that maximum minus minimum equals 2? No, it'll be maximum minus minimum divided by 2 equals 2. So I want you to think about this. If its amplitude is 2, that means the maximum minus the minimum, you might want to write this down, divided by 2 equals 2. So if I did a little math here, if I wanted just the maximum minus the minimum, how would I get rid of the dividing by 2? I'd multiply it by 2. And so we can actually say, I'm going to draw an arrow this time, that the maximum minus the minimum will equal how much? 4. And so that means I'm going to go as high as 2 and as low as -2. And I'm going to center this on the x-axis. I'm going to put the midline on the x-axis. So here we go. I'm going to start as a cosine wave. What does that mean? I'm starting at the maximum. I think it'll be easier. So we start at 2. When I get to 3, I made one full cycle. So walk me through, what's the halfway point between 0 and 3? At 1.5, we should have our minimum for this sound wave. Because it's a wave, I'm going to try to round it off, which means let's label where the x-intercept would be. What's in between now 0 and 1.5? 0.75. Guesstimate where you think 0.75 is. And now what I want you to do is try to round off your graph a little bit. Because it's a wave, it's not a sound line, it's a sound wave. And so the way they work, they're kind of rounded a little bit like this. Try to round it off. Okay, now I want to continue on. The next 0 should be 0.75 further than 1.5. What's 1.5 plus 0.75 more? 2.25. Guesstimate where that is, put a point. That's where you're going through next. So round it off, come up, and round it off again. Like that. Whoops. Okay, now, just to help yourself out, save time, what I want you to do is take your pencil, highlight what you just done, and right-click with it, and hit clone. I'm just kidding. Yeah, just continue on in your pattern. And you can actually do this 3 times. Just continue on in the whole pattern 3 times. Whoops, that's not what I want to do. I lost mine. I got to do it again. And just fill up your graph here, trying to follow that pattern. Okay, I'll give you a moment to do it. Once you get to 9, you can wrap it around and draw your arrow. So I'll curve it around and draw my arrow there. As you're drawing, I'm going to just add some stuff in the notes. What do we call a maximum to a maximum? That's one cycle. By distance, the distance is equal to, different vocabulary word. The distance is 1 period. Very good. That's one cycle. If I drew the amplitude, I would go from maximum to midline. That was so ugly. Let me try that one more time. Let's see if I can go straight down this time. Closer. Still ugly. That would be the amplitude there. All right. Now let's make a note of something that might be confusing. It said the amplitude is 2. Does that mean it goes from 2 to 0?
No.
It goes to 2 to -2. Total distance of 4 units up and down. But remember, it's maximum minus minimum divided by 2 for amplitude. That's amplitude. I'm gonna just say A equals here, or amp equals, there's the amplitude. All right. Is that enough time for you, or you still need more time to draw and label?
It was like 10 moments.
All right. Moving on. Example 3. Now it says, consider how the pedals on a bicycle rotate as the bike is being ridden. I thought that was such a weird word when I saw that, ridden. As you ride your bike. Now here's what's kind of confusing for some students to get around on trig first. So I'm going to pause here just for a second to explain this. When you think about pedaling a bike, I'm going to use my hands to represent the wheels. What shape, if you were to draw my hands, what shape are you creating here?
Circle.
A circle. What's going to happen is a lot of trigonometric properties we're going to represent by a circle. Or you might talk about, like, say, instead of a bicycle, maybe a windmill. The blades on a windmill, what shape do they make as they spin? Circles. But what they do is they put it on a graph, and instead of having it as the x and y, which would make it look circular, an x and y where you're locating the points, what they're going to do is when they put it on the graph, they're going to change the x-axis to becoming a t-axis. Now, what do you think t stands for? Time. And so the graph will begin to look like a wave, because as time moves forward, you're going to graph the y values and how they go up and down on your pedaling your bike, how the y's go up and down. As you start to put it on an x-axis, it's going to look like a wave, because as time moves on, the y's go up and down and up and down. So that's how a circle starts to look like a wave. We're going to talk about that more next lesson. All right, so starting with this one, let's first fill in this table. It says the height of the bicycle pedal varies periodically as a function of time. The maximum height is 18 inches and the minimum height is 6 inches. So 18 inches here. This is 15, 12, 9, 6, 9. What number would go here? It's periodic. It should be repeating.
12.
12 then. And then finally, 18. Okay, now one thing I don't like about this problem is they use a real world situation, but they give bad data. Because when we plot this, you're going to see that it doesn't look like a wave like it should. Let's plot this. Notice this is not an x-axis. What letter do they use on this axis down there?
Time.
T for time. H of t is the height. So at time 0, we have a height of 18. They didn't label this, so I want to put t here and h of t here just for the sake of the notes, just in case there's any confusion. So we're going to go 0, 18, plot a point. Now at 0.25, we go to 15. At 0.5, we go to 12. At 0.75, we have a height of 9. And at 1 second, we have a height of 6. Starting at 1.25, the pedal starts to rise again. Now we're back to 9 inches. 1.5 is now 15 inches. 12 inches, I'm sorry. 15 inches at 1.75. And then finally, at 2 seconds, we arrive at 18 inches again. Now, there's a problem here. They did not give us very good, because do these look like a wave to you? It looks like a V, or it's linear in the sense that they're not looking like a wave, which they should. They should look like a wave, and you will see next class why it should look like a wave. But this is the data they gave us, so we're going to use this data, though that would not be realistic. Okay, so let's go plot the next one here. And again, just continue on graphing. I'll give you a moment to catch up on the All right. If you're still then, and we'll continue on just a moment. So we have completed the table. So I'm just put a check. We've done that. What we have not done is identified the period of the function. So you can either look up here or on this graph here. If you're looking at the visual of the graph, what do you look for? Maximum to maximum. So here's the deal. If you're gonna look at the table, you do the same thing. You look maximum to maximum. If the maximum is 18, where's the next maximum up here? 18. That's right, right there. So you're looking at what's the distance between 0 and 2. So that one cycle there, the period is 2 seconds. Now, the letter they're going to use for period, I'm going to go ahead and include this now, is K. This is 2.0 seconds. And I'll use the unit this time. They said it's in seconds, so I want to say 2.0 seconds. K is your period. What is K? Your period. That's going to come off in a second. We're going to use that definition from the very front of the packet. That's what the K refers to as the period. Now it says identify the amplitude. How do we find amplitude again? Maximum minus minimum over 2. What is the maximum height here? 18 minus, what's the minimum height? 6. This is the first time we haven't had a positive minus a negative. So this time it's just 18 minus 6. What is 18 minus 6? 12, and we divide that by 2. 6. And they gave us units on this as well. They told us this is in inches. By the way, they use the little letter A on this one. That's what you use for amplitude, is the lowercase a is what that will be. And it says graph the function for the first 5 seconds. Well, we've already done that. So I'll put a check mark there. We've done that. Questions over that before I send you off to your next DOL? All right, go ahead. And I want you, here's some verbal, you don't have to do the graphing this time, but I want you to think through, when they say cycle, what is a cycle similar to in distance? Audrey, what do you think? The period, yeah. It says a periodic function goes through 5 complete cycles in 4 minutes. What's the period of the function in seconds? So a synonym for cycle is periods. You could look at it as periods. That's the same thing. Those are equivalent to one another. It has 5, except you wouldn't have to use the word complete. That would be redundant. A period is a complete cycle. So 5 complete cycles is the same thing as 5 periods in 4 minutes. Last thing I'm going to ask, in 1 minute, that's 60 seconds. Good. Okay, I want you to do a little math to figure out how long does it take to do 1 cycle. And then you can go through the rest and doing those, but I'm just going to pause it there and let you work for a moment. All right, let's look at example 4 here. It says, consider the periodic function shown. What is the period K of the function? Now, what's the easiest way to determine the period? Find a maximum to another maximum. Labeling a cycle right there. That will be the distance of 1 period, or you could say it's 1 complete cycle there. So I'm going to take the maximum minus the minimum. On this cycle, what's the maximum x value? 2. And I'm going to subtract the minimum x value. What's the minimum x value? -2. Okay, when you take a positive and subtract a negative, essentially you're adding. What's 2 plus 2? 4. Now again, I'm just going to say units because it doesn't say what the type of unit is. So it's 4 units. That's what K equals. It should say K at the front. Now it says complete the function behavior on the grid. All right, so what's happening here when I need to decrease here. What's happening when you go to decrease? You go down how many units?
4.
Ooh, not 4. 5, and go over 1. So it's going to be right there. So I go down 5, over 1. And then when it's time to repeat and go to increase, what's the slope there? I go up 5 over how many? 1, 2, 3. Oh, I agree. I was thinking it was 4, but y'all right. I go up 5 and over 3. 1, 2, 3. Just like that. And now we repeat. I'm going to go down 5 over 1. And then I begin to go up 5 over 3, which would take me off somewhere over there. Something like that. And I guess over here, I could add this one in just to have a complete graph. Goes down 5 over 1. So I'll add that point in as well. That line. All right, we've completed the function behavior. And it says show that f of x equals nk is valid for n 1, 2, 3. And here's the deal. You can use negative numbers too. For any minimum value on the graph, for any minimum value. Okay, so we're gonna use a minimum value here. So someone just choose a random minimum, which give me an x value that has a minimum.
What?
How about -1? You see how this has a minimum right there? We're gonna look at f of -1, which equals -2. We're gonna look at this minimum. So I'm going to show you that f of -1 is the same thing as f of, here, notice what's my x value?
All right, -1.
-1 plus, now someone just pick an n value at random, either 1, 2, or 3. I heard 3 first. We're gonna do 3 plus 3 times, what's our k value? 4. And I'm gonna show you how we get the same number here. All right, when we go to simplify this, so color coordination, I chose 3, n of 3. That's what that is. K is 4. We solved that earlier. Okay, let's simplify. This would become f of -1 plus, what's 3 times 4? 12. And what is -1 plus 12?
11.
11. This says that f of 11 would equal f of -1. Well, let's check. So where is f of, here's 11. What do you get at f of 11 as the y value? -2. Tell me, are those equal to each other?
Yeah.
Wow.
You see how that worked? This is that definition. This is the mathematical definition of a periodic function. So what is everything referring to? Now that we've done all this, I'm now going to explain what everything refers to. K is the period. Okay, what this is saying to be periodic is if you have any function value, you can pick whatever you want. We chose a minimum. You could choose any number, it doesn't matter. If you also take another function value, same x, but you add a certain number of periods. This says 1, 2, 3, 4, but as I corrected on the notes earlier, it can be any integer. It can be -1, -2. If you add or subtract any number of periods, you should always get the same repeating y value. That's what this definition means. If you add a certain number of periods, remember K means periods. If you add a certain number of periods, you should still get the same y value. So in this case, we should always end up with a minimum. Does that make sense? So if we would have plugged in a 1 for n, we would have got the minimum at f of 3. If we would have plugged in a 2, we would have gotten 2 periods later at f of 7. See the math? We plugged in a 3, so we were 3 periods forward. So 1, 2, 3, f 11. That's where it showed up. Does that make sense now? That's what this means. It's just the definition of a periodic function. Okay, you have 1 here that I want you to plot out and then find the amplitude and the period. All right, example 5. Now let's put this together and see how fast we can go through these. Define a period. What are you looking for?
Yeah.
The x values from what I would recommend a maximum to a maximum. So here is one cycle I'm going to label. One cycle. What's the first maximum x? Not the first. In this cycle, what's the maximum x? 2. What's the minus? What's the minimum x? -6. What is 2 minus the -6?
8.
8. And so this does not have units on there, so what the units are, so I'm just gonna say 8 units. That's our period. What letter would the period be? K. They would use the letter K. Okay, amplitude. They would use that A, by the way. How do you find your amplitude? Maximum Y minus minimum Y divided by 2. What's the maximum Y? Minus the minimum Y divided by 2. Minus a negative turns positive. What's 3 plus 3? Divide that by 2. 3 units. Okay, the maximum. Okay, so the maximum would be 3 and the minimum? -3. Very good. Now, intervals of concave up. That means the graph is increasing in slope. So it's going to be these intervals in here. And this can be tricky to write. Here's what I'm going to do. I'm going to write this first one. This is the interval from -4 to 0. So I want you to write from -4. And then instead of doing a comma, this will repeat how to get the -4. The next interval that's repeating is 8 units later. You see how it's 8 units later? Because that's K, a period later. So what we're gonna do is plus NK. So -4 or any NK, comma. And how long does it continue to increase? Nope, until 0. Here it starts to become concave down. I shouldn't say increase. You would do 0 plus NK if you wanted to simplify. What is 0 plus NK? NK. You could just write it as NK. Okay, and with intervals, you use parentheses, not brackets. Now, what about concave down?
You could do -8.
Very good. -8 to -4, but this repeats every period, so put NK. And then it would go to -4 plus NK. You could use that one. And for both of these, you would need to write where N is an integer. N is an integer. Integer symbol is the double Z. The points of inflection. I want to draw them here. The points of inflection where you change from concave up to concave down. So those would be the points of inflection. At 0, 4, 8, these are the points of inflection here. So what you could do here is, I'm just going to say, you know, what's 0 plus 8n? I could have reduced that. What is 0 plus 8n? What's 0 plus anything? Whatever it was. I could just leave that as 8n like that. The points of inflection would happen every 4 units. So you just say 4n, comma 0. The y value is always 0 there. Where, again, where n is any integer. The reason this is not one period apart is because there's 2 per period. So like that. Those are the points of inflection. Which will bring us to your next DOL. I'll allow you to do the same. All right, example 6. A storm siren makes 2.5 rotations per minute. I want to pause here. A rotation is a cycle. 1 rotation is going to be equal to 1 cycle. And a cycle is the same thing. The distance of a cycle is the period. So it's saying 2 rotations, 2.5, excuse me, 2.5 rotations, which some people will call the revolution, per 1 minute. What you can do, whoops, if you had to convert out of this, the 2.5 revolutions, that's a full cycle or a period. Okay, so it said here rotation, that's the same thing as a revolution. All that's equal to 1 period. So if you had to change that, they're gonna change it to seconds. What you would end up doing is you do 1 minute over, not equals, I'm sorry, we're gonna multiply times 60 seconds. And when you simplify, you can find out what 1 period is equal to, or 1 revolution. So here, minutes cancels with minutes. Let me change colors, sorry. Minutes cancels with minutes. And so 2.5 revolutions per 60 seconds is the same thing as if you divide that out. Let's just use the calculator. 60, how many times can 2.5 go into 60? 24 seconds. 24 seconds is going to be 1 period. So if 1 revolution would equal 24 seconds, then 1 period is the period equals 24 seconds. That's what we just discovered there. Okay, so anyways, continue on here. And the sound waves have a radius of 1 mile. So this is talking circular. That's why they use rotations. So the radius of 1 mile. Mr. Tyler's house is located 1 mile south of the siren. The distance the sound waves from his house varies periodically as a function of time. What is the period of the function? Oh, we just got that. It's 24 seconds. Okay, that's what I did all up there. So I'll put here 24 seconds. 1 cycle or 1 period. Oops, forgot the I. There you go. Period equals 24 seconds. Now let the x-axis represent time in seconds from 0 to 60 seconds. That means 1 minute. So we should have 2.5 cycles in here. Let the y represent the distance the sound wave is from Mr. Tyler's house at any time t. The siren begins its rotation facing north. So we're 1 mile south. So the siren starts 1 mile. So if here's the location of the house, let's just say distance wise, we're 1 mile south of the siren. So we're here. Well, that siren actually, it says here, the siren begins its rotation facing north, and it has a radius of 1 mile. So it actually starts here at 2. So this will be like the center location. This is south, so north, south, if you will. Here's the center. The center is here. So we start 1 mile to the north, and then it takes 24 seconds to go all the way back to here, which means the minimum would be at 12. So this would actually go through. I want to round off the edges rather than making them linear, because that's how it's technically going to work in the real world. And then you would repeat that. And so there's 1 cycle. I would have another cycle that would take another 24 seconds. And then I'd have half a cycle by the time we hit 60. So by the time we hit 60, we've had 2.5 cycles. So I think I have that graphed accurately. Again, the midline is here, and notice that it says its radius is 1 mile, and go 1 mile this way and go 1 mile that way. And we are located 1 mile south. So this would be the distance. This is the distance from the siren to Mr. Tyler's house. So it comes, and here, its distance, it would be right there at 12 seconds. The siren would be at Mr. Tyler's house. So this line right there, that represents the midline. Let me add that in there. Since we haven't done that in the last few examples, that's the midline. Okay, now with that, I'll give you your last one. Here's your last DOL. You go ahead and fill out all this information on the Ferris wheel. Remember, a revolution is the same thing as a rotation, which is the same thing as a cycle.